Welcome to Science Center. Ew, the thing is so dirty. Yeah.
Stress? Ang tubig sa doon.
Ang robot oh. Nagkaaroon yan sa Science Center. Batman lang.
Oh, picture. Picture.
Uy. Sobra pa sa long neck. Movie ka din.
Wala puting na rin. Ito ka, puting ah.
Eat pudding, oh. Pudding is delicious.
Ay, apilihin ko. Galing-liho na raw. No! Kuya?
Oh. Lumita na on. Hey, watch your step there ha. Chewy water world nga.
Oh, the baby. Sa kanipag ko, no? Design, ha? Grabe, oh. Wonderful.
Hi, Dai. Hi to the camera. Hi. No, don't like. There, there.
Alang di matiyo. Ang work sa isang.
Ano ni? Gawas ng top. Ubus.
Tapos upat isa buwan pala.
Ano magani?
Grabe nga design, no? Okay, kaya.
I'm sorry.
Always.
Hugaan ibig ko ngayon. Allah.
Ha?
Amugi mo tao.
Oh, kita ba?
Kumpra.
Kita mo kurong karon. Oy, what are animals? Animals? I'm an animal.
Maano mo?
I'm a shrimp. I'm a frog. What are fungi? What is fungi? What is fungus?
Yeah, they have unbounded love of life and death. Yeah.
Hanapit mo.
Winter and wonderland.
Oh, mabay. Styrofoam lang. Oh, lens pa yan. Oh, telescope sa kreton.
One, you're the map girl.
Si TV rin bahala.
One.
So we're going to Snow City. UV? UV like?
Ulit na movie.
Dia kan ni, dia dua.
Tigang median makibuk-kibuk.
Pinay lang. Kiram daya gapon. This is alive. Puding, let's go na. I'm very sorry. One, wait, one. Wait, Dave. Happy di ba? Happy di.
Kita no?
Dubai. Ako tao, usog.
Tao gani.
Ano saran?
Okay, doon na.
Kadali lagi saran.
Asti.
Ganda-ganda pa ya.
Pati ang kantahan ko ya.
Ha?
Pati ang kantahan.
Pertan, lihat sabihin. Sana ako may na point.
Nasa?
Mo-color lagi yan.
Kain.
Sana walang kuha na point.
Tapos?
Makita mong color. Focus gaya, focus gaya.
Kita.
Focus lang mo kuha. Kalibat mo.
Magkakuhay. Magkasabot.
Huh? You need to be here? Wala yung feeling ko eh. Marang lain na feeling ko. Sabot. But,
Nasa ulit sa
yung kunik ko nga. Hati na yung kala ba yun? Yeah, mo. Suot ko naman ito ah. Ano may tabo? Siyan, kuhan. Maka mahog. Kaya film mo no? Kaya rin mo. Puasa? CCTV kaya? Kaya? Ay, amo ka di pasabot. Ay, siya anda. Mahimo yan na box. Sus.
Ay,
Ano?
sus.
Sus na dyan eh. Ako rin ang box. Sus ka. Ah. Sige ako. May tara pasabot sin eh.
Kata na.
Siya anda. So, mabox ka diyan. Pag masud ka. There you go. Ah. Kabidyan ko dito. Saan kayo modagan nga? Tanaw sa? Modagan niya.
Ano kita? Paano?
Ano yun sab? Mahimay ng bubay. Palibatan ka ng mata. Ikan, isa lang. Palibat ba? Yan, libat.
Nasa?
Basta palibat lang. Kita akong chicks. Marilyn Monroe. May tapos yun. I don't understand a thing. Wala. Never mind.
Baka kita.
Ano ka?
Basta kita.
Oh, ganyan kita. Ah, there you go.
Kaya ito kuya?
Something like this. Ay, nito, insert point. Masagaw.
Ano ba yan?
Galiyok na nat. Mahilig ba? Uy, bulag. Hindi, makita nga ni Karoy nga eh. Possible color.
Sige, ano mo dito, pa-picture mo to ninyo, no?
Kain.
Ato po, tatilisil din mo. Tanaw mo picture. Tanaw mo picture.
Kain saan?
Kaya mo picture to putol, no?
Ayun, no?
Ah, dapat.
Ayun, no? Nakasmile.
Dali no, picture mo, listen.
Kain.
Ito pa sa
Karoy nga din. On, pagkala.
Okay. Okay. Gawa ako lang sa.
Hindi ganyan madaya sa kuhan guys. Dark places. Pero masyado lang ba?
Ayun ang taas sa akin.
Masyado lang sa advertisement. Ikaw pwede sa papa.
Good. Masa lagi? Ito na, isa ko magkati.
Kaya yan.
Ito ra.
Kaya sa akong puso. Chuy. Ay, suy. Kurmakuhan ko medyo. Ayun, pagkaw natin.
Maguling look pa niya, look. Kurma tornado. Kurma tornado.
Kurma na doon.
Kurma na kayo lang.
Ato gani. Ito, tunasa na natin.
Oh. You might fall down.
Pwede na lang kayo, wilok tayo sa isa.
Ito ra.
Uy.
Okay. Na. Kaya.
Sorry. Sorry. Ako na tayo si Carillo.
Tara, mapiyaan mo ni.
Inaw. Kachuita naman eh. Nadi mo kaya sa kanang kuhan.
Welcome to the sound exhibition.
Ito, grabe. Ping-ping lagi ka na
Ano
ako.
man na? Ihi?
Pag-iyan, pag-iyan mo.
Hindi ako rin eh.
After a while, ikaw
Pushing touch. Here goes. 1, 2, 3, start. Ah, I see.
Nice. This one is
Let's have some sun. Snork as well.
Here, here.
Let's go to the other side.
Okay.
Kuya,
Count ba?
balik.
Okay, go. Singing bowls.
Ha? May sound joke?
Na, bakit may show sila?
Use the short mallet to rub the outer of the ball. Zero of the ball will start to sing. Try another bowl. This is Oh, hindi naman. Tingnan paspasan. Make it faster.
Ano na siya?
Tara, tara. Hinay lang.
Ha?
Hinay yung kanta.
Wow, kadungog.
Lai.
Wala.
Buting nag-cook na.
Kuya, itira lang ko ito rin.
Ayaw, magkurog-kurog sa good. Yan eh. What do you do as friend stand on the opposite side? Opposite one na. Opposite side.
Ha?
Opposite side.
Tapos,
Talk to your friends daw. Ano to? One. Sos, parehas na. Parehas na sa... Ay, wala pa si paburot to. Create music using your body. Yeah, this is rap music. JB, yo,
tingnan na.
yo, JP. Yeah, we're gonna make a music. Yo.
Wala ko na sili, kuya.
Pili kang music. This is rap.
Yes, it's up.
Ito. Saan?
Ha?
Ano saan? Ano saan ba?
Ay,
Napunta na saan? Pero si Kuya. Ay, tele.
sige na.
Magnet. Apa ini?
Ha? Music.
Nag-share sa monitor dong. Ito, nag-share sila.
Hello? What? Blah 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 blah. Blah 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 blah. I understand you. Kaya pa rin nilibutan.
Yan na, isa-isa.
Ay.
Packed nucleosomes known as chromatin.
Ay, lamin eh.
Loading ulit. Loading.
This structure is then
Eh, paano kitawan sa pedestrian sa eh?
Tinan mo sa line. Okay.
Ilag siwan eh.
Ikaw.
No way.
Cars! McQueen! Kaya madali ka? Mag-i-start.
Dito, all seat.
Ya kan niya kitawa pa. Lah, cuy. Mas pwede din yan. Coba sa kunay. Mamat dah, pila ito? 9. Stop na. Doon lang. Optical illusion. Optical illusion. Parang straight lang kita, no?
Oh, hindi ka ang picture ba? Yan ang picture.
May tabo ka, hiwi.
Kanto picture ani mo may arit ta.
Di, sino na sa amin? Di, sino?
Sa amin.
1, 2, 3. Balik ka na, no?
Balik na, perfect.
1, 2, 3.
Ay, yan. Sit down. Tapas.
Bading!
Itong kaya di mga ngaran. Tingnan ko yung mga display. Production ba? Pag-produce ba? Diyan mo, hay.
Do you take picture with Uncle, oh?
Uncle na dahil. Uncle.
1, 2, 3.
What I see here? No.
Is that a toy car? Come here.
One coin, 16 minutes. No way. Ay, restaurant. One, may dua kayo itong isa. One, may dua itong isa. One. Kaya nabitan ka? Hindi tayo mamove. Nope. Nope. Tara. Yan ay pa-discover ng kanang way. Yan. Okay, nice. Pipi yan.
Dago ya, pipi.
Ha. Ben. Dua ka?
Stiso. Tipulyo. Ari kata ko ni Rabbit Tart. Gag na yan.
Pagpagay ni.
Nawa. Tananga.
Oh, sige.
Ito ang buwag. Ito ano? Ito na sa. Baliktad. Ini kay Astigi.
Wala.
Put it here and you buy like
Dolphin na, dolphin. Dolphin sa taas. Hindi ho.
Your squirt
Puno ini?
Ayan na, buding. Ayan na.
Sige lang, papailan ko na.
Wala kita ka daw.
So, sisahin pag yun ako kurik na malaktak.
Start na. Kus, marung dadahin kita.
Never ma. Ay? Nothing. Nothing. Delicious. Ah, it's so hard eh. You press. I-press mulutaw. Daot naman guro. Mulutaw mo ni.
Daot na.
Dara mo kaya.
Uno ka rin ito.
Ocean water also contains dissolved gases that are constantly being absorbed or released at the ocean atmosphere interface. Threaten to warm Earth's atmosphere. Some scientists think the excess carbon dioxide will be taken up by the oceans.
Ay, video.
Others are not so sure. If the oceans can't absorb this excess carbon dioxide, how might this affect Earth's climate? Oceanic crust with sea-like intricate and convoluted container.
Sus, kanon na ni, di kabusog.
At least,
Ay, grabe, no? Minit.
The continental
ito
slope
kay kamay na taas.
and the continental
Lain na yung focus ay.
Budi!
cholera.
I love cholera. Ano siya? Cholera.
Oh, grabe.
Hi, kuya!
Actually,
Galing ko kami yung picture ni Minzy.
Opo. Hindi siya makuha.
Strike the cola inside the samodela. Send the mama kind of microbacteria.
Ang toki.
makita mo sa rayo, ma.
Ha?
Makita mo lang sa rayo.
Ang ulo?
Ito.
Sige, makita ko.
Sige kulay.
Hindi pa gayad. Ma. Okay nga lang. Okay, focus. Ah, sa earthquake. Ah, okay. Walang uyab, good. Watch the rain fall in slow motion. Slow motion sa yan. Wala, tornado! Diba, Japan! I'm on the court! Kyo! Oh! Don't ever touch that. Don't say anything. Science fair. Science fair. Punta siya para matatestan. Uy. Oh. Tukoy ko ah. Ah. I see.
Kadi abi suara.
Masa?
Sito.
Kita mo. Hala, tanawa.
Yan, kitan ka ng kamera.
Eh, bato.
Hindi, katigaw.
Degrees Celsius. These hot solar rocks have floated at a rate of a few centimeters per year. Look at that! One lithospheric plate is subducting
Don't go inside there. Underwater earthquake. I thought it would be controlled here. Starts in 5. Ah, there you go. Let's try another one. That's so long. Okay, let's try underwater volcano. Volcanic eruption in the ocean, either underwater explosive. Budi. Hi, girl. Ora. Hi. 5, 4, 3, 2, 1, 0. Ay.
Sabay na. Apoy. Gimbal. Wait first. Wala?
Pindot.
Akala ba yung Pedro?
Hi, 40 lang.
Next, click. Next.
Kala ka mo dito. Mas na Joper. Ako ito din.
Hi.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Ay pa, tanata pa. Tanata pa. Lita. Andiyan ko na kita. Kasi. Ano yan?
Seems to aid you. The weather's going all funny.
Don't pat it, dude. It's not strange weather. We're at the North Pole. It gets 24 hours of daylight during summer.
No, I'm sure the climate's changing. That's why the weather's gone weird.
Picture mo to.
We should acknowledge to reduce our costs. But there will be devastating consequences if each community runs in ambition.
Oh, take picture.
Ang tiil. Hey, Buddy!
Saya sabihin mo.
I think that anecdotally there's lots of evidence of global climate change.
There's no question that part of the cause is human activity. The question is how much of the cause is human activity.
Different health effects.
Hello. Hello.
Hey, guys.
Hello.
Guys. Yeah. Can we turn have to talk to these people here. Yeah, thanks. No, you can hang around. Okay. Hi. This climate change issue has got them all upset. In fact, that's why I'm here to talk to you today. Because frankly, we're all a little worried about climate change. Now, I may be a sheep, but I'm an informed sheep. Yes. We sheep. We hear things. Let's face it, we're out there living it, on the edge of the storm. Okay. A thin blue atmosphere that gives us oxygen to breathe, protects us from the sun's harmful rays, and acts like a fleece that traps heat to keep us warm. Okay, so we're pretty lucky to have our atmosphere. But maybe you knew it. But did you know that our atmosphere hasn't always been this way? The early atmosphere was mostly carbon dioxide. With no oxygen, there were no animals. Like you, or more importantly, me. The earliest life on Earth were tiny bacteria, all sorts of strange protozoans living in the sea. Early on, maybe 3 billion years ago, some of these creatures began to make a living by breathing in some carbon dioxide and breathing out oxygen. Now, you have to picture this, because it's a really big deal. Hundreds of thousands of little green creatures taking carbon out of the atmosphere and breathing oxygen into it. When they died, they fell to the seafloor, taking the carbon with them, trapping more and more carbon in the sea sediment. So, we've got oxygen filling the air. 1%, 2%, 3%. And after a while, a new life form appears. Ancestors of all animal life like you, and who breathe in the oxygen and breathe out carbon dioxide. Now, some things putting carbon dioxide into the atmosphere, and other things taking it out. A cycle was created. We call it the carbon cycle. This cycle keeps things in balance. Most of the carbon safely stored away in the ground and oceans, and only a tiny bit out of the atmosphere. It's pretty amazing. Life created its own 4 billion years in the making. What's more, every animal we see around us today, sheep and humans, has never known a different atmosphere than the one we have today. It would be hard to think of a way to improve our atmosphere. Think of the amount of carbon dioxide in the atmosphere, a fraction of 1%. It might not seem like much, but it is vitally important. Carbon dioxide is a greenhouse gas, one of the important gases that traps some of the Earth's heat and keep the atmosphere at a cozy temperature. Without greenhouse gases like carbon dioxide, methane, and water vapor, our planet would be about minus 18 degrees Celsius. Instead, because of the greenhouse effect, the Earth is on average a cozy 15 degrees Celsius. Of course, in everyday life, we don't usually talk about the Earth as a whole. If an alien phoned me up and said, "Hey, sheepy, I'm passing by the Earth. What is the weather like down there?" I could answer, about 15 degrees, but that wouldn't be very useful. 15 degrees is the average temperature of the whole Earth. Most of the heat starts off at the equator. From there, it is carried over the whole globe in different amounts by air and ocean currents. The amount of heat a place receives over a year has a lot to do with what type of weather it gets. Apart from how far you are, north or south of the equator, there are many factors that can make up a region's weather. A mountain range here, a lake over there, and it's the pattern in the weather that gives it its particular climate. Yeah, we've got a pretty sweet deal going on Earth. Every living thing is adapted to one climate or another. Oh, cool. I really hope that nobody does anything that might upset this delicate balance. I won't mention any names. But you, humans, have developed some pretty peculiar habits that just might spoil things for the rest of us. What habits, you ask? Here's your first clue. Recognize this? That's right, the electric can opener. The holy grail of labor-saving devices. Where would you be without it? Second clue. This is what the Earth looks like at night. Okay, who turn off the lights. Huh? So what's my point? You humans use a heck of a lot of energy. But the problem is how you make this energy. Most of the energy you use comes from burning fossil fuels, coal, oil, and gas. Now, remember the carbon that got stored away in the ground over the 4 billion years of the Earth's evolution? Yeah, that's the carbon you're burning. And when you burn fossil fuels, and you put that carbon back into the atmosphere, you're messing with the carbon cycle. Ever since the Industrial Revolution, the amount of carbon dioxide in the atmosphere has been on the rise. So the question is, since carbon dioxide is a greenhouse gas, and there's more of it in the air, will the atmosphere trap more heat? Is our planet heating up? Well, why not find out? I'll just ask around. Hey guys! Have you noticed the Earth getting warmer lately?
Now, I think the sun looks brighter today. When I was a lamb, the snowbanks were as tall as the barn. It used to be so cold, I had to wear 2 sweaters.
The grass has been getting greener.
Okay, so there's no help at all.
No, wait, it's greener over there.
No, really. Really, thanks, guys. See, when you talk about climate, you're not talking about last week's heat wave, even how bad winter was that year. No, you need to look over a long period of time. So where do you start? Well, humans have been keeping pretty good temperature records for the past 140 years. So let's start there. It's the last bit at the end that worries people. Temperature is rising, and it's rising very quickly. In fact, the 1990s were the warmest decade in the past 140 years. But the trouble is, even 140 years still isn't enough time to be sure that something's out of the ordinary. Maybe the temperature rises and falls this much and this quickly all the time. Enter climatologist, type A, the adventure seeker. He spends his life traveling the world, diving the ocean, scaling mountains, looking for clues to the Earth's past climate. Anywhere where things get laid down year after year in layers. The growth rings of trees and sea coral, the layers of ice collected on ice caps year after year. By looking at these natural records, climatologists can figure out the temperature trends over thousands of years. And looking at just the last 1,000 tells us that the rise in temperature we're experiencing today is something unbelievable. Okay. Don't get your wool in a knot. We don't know how bad things will get. Maybe the Earth has a way of dealing with our pollution. But just to be sure, we better call in climatologist type B, the climate modeler. The climate modeler wants to figure out what will happen to the Earth's climate in the future. Not a very easy question to answer. It can only be done with a supercomputer, lots of data, and some very clever science. As far as my woolly brain can tell, the modeler is building an important model of the Earth inside his computer so he can run experiments to see how the Earth's climate will change. This is what a typical computer model looks like. This one predicts changes in temperature over the globe for the next 100 years. Scientists all over the world are creating models to predict climate change. Depending on the model we follow, they tell us that the Earth's average temperature will rise between 1 and 6 degrees Celsius over the next 100 years. So there you have it. Scientists pretty much agree that the Earth on a whole is heating up. Is that so bad? Will we get longer summers? Less snow to shovel? Fewer wool sweaters? The fact is that climate change will affect different places in different ways. Let's start with the obvious. When you heat ice, it melts. For the past 50 years, submarine pilots have been noticing the Arctic ice sheet melt by 40%. And this climate change affects everyone who calls the Arctic their home.
What's scary is that there's uncertainty because we don't know when to travel our food sources are getting further and further away. We can't read the weather like we used to. It's changing our way of life.
What are doing to like birds?
Another effect of melting ice is that it adds water to the oceans and will make sea levels rise. Even worse, when the oceans themselves heat up, they expand a little, causing the water to rise even more. Many of the world's cities are built within a few meters of sea level. Some, like New Orleans, are even below. Entire cultures will be at risk. For instance, the South Pacific islands of Tuvalu rest on land only a meter or two above sea level.
Tuvalu fears about climate change and sea level rise are very real. The sea is our very close neighbor. In fact, on the island where I live, Funatuki, it is possible to throw a stone from one side of the island to the other. Our islands are very low lying. When a cyclone hits us, there is no place to escape. We cannot climb any mountains or move away to take refuge.
Now these are the straightforward examples, but the changes don't stop there. When the atmosphere heats up, a lot more water evaporates. In some places, this will be like a big hairdryer drying up the earth, stressing farmland around the world. And here's something else to think about. Because more water vapor is evaporating into the air, storms will be a lot more powerful and carry a lot more water with them. So we can look forward to more severe storms, and with them, more floods.
The result of climate change. More disasters.
So, here is the challenge. How do you humans stop creating so many greenhouse gas emissions? Yeah, that's right. I'm looking at you. There are many ways to go about reducing your greenhouse gas emissions. Energy efficient appliances, turning off the lights, unplugging the electric can opener. I will leave it to your superior human intellect to figure out all of the solutions. Reducing how much energy we use is only part of the solution. The long-term fix to climate change will come only once we stop using so much fossil fuel, or even kick the habit completely. There is no one solution, and that, in a sense, is the solution. In the future, how you make energy will depend on where you are in the world, what climate you live in. In a desert country, solar energy might be worth a try. Up on a hill, maybe a wind generator or two. Cars are another challenge. You need a source of power that can roll around on four wheels. Not a problem.
Yes.
The latest thing in clean power is the hydrogen fuel cell. Think of it as a clean battery. A fuel cell runs on hydrogen gas and mixes it with oxygen from the air to make electricity. The only exhaust is a bit of water vapor. Now think big picture here. Let's put it all together and see how a city of the future might create its energy. Say you're living near the ocean. So you throw up a couple dozen windmills just offshore. There's enough electricity from those beauties to power a small city. But that's not all. Now you use some of the electricity to turn normal seawater, H2O, into hydrogen and oxygen. You pump the hydrogen into the city, and now all your cars and trucks can run on hydrogen fuel cells. Does all this seem a little far-fetched? From where you're standing right now, it might seem that way. But already around the world, there are cities and even whole countries committed to running on hydrogen within the next few decades. It won't happen overnight, but it needs to happen sooner than later. Our Earth's climate is already changing, which means all of us have to adapt. But if you start working on the problem now, we'll all avoid bigger problems down the road. And I'm not saying I don't have absolute faith in you, but just in case, I'm going to keep these boots on for a while yet.
Let's go, let's go. The solar panel and pump for this exhibit were kindly sponsored by the Shell Solar. Madhita rin. Ay? Sira na. Bye-bye. Inquiry.
Welcome to the Balloon Science Show. My name is Prabha.
My name is Andrew. Hello.
Wow, I like her. Okay, so let's get started on Balloon Science Show and you.
Okay, so what can we demonstrate about balloons? What's the best thing about balloons? They can burst. Some say it's the worst thing, and some say it's the best thing. But yeah, one other thing is that they can fly through the air.
Wow! So you're going to make these balloons fly through the air.
And how do you do that? Oh, yeah, we can do it different here. Very light gas, that's a good suggestion. But even just with normal air, balloons can fly through the air if you do not tie them. Yeah? When you let go, what's going to happen to this balloon? It's going to fly. So we call it a rocket balloon. So can we have a countdown from 3, 2, 1, blast off.
Whoa!
It's going. Landed.
Ah, she's the lucky one. Alright, so it looks like we are giving out some balloons, right?
Yep.
Okay, so let's give this one out. Who wants this yellow banana looking balloon?
Okay,
1, 2, 3.
Okay, let's do some more. This one.
More coming your way. More balloons. These balloons are big. Okay, let's see. One orange one coming your way. Who wants this beautiful orange balloon?
Oh, that's right.
No
And
one.
right at the back over there.
Okay.
And okay, who wants this one? Yellow one. This side? No? That side over there? Alright, let's just...
Whoa, be careful, okay? Okay, you cannot come to the front. If you come to the front, no
Only
balloons,
for those
okay?
sitting down.
Yes, only for those sitting down.
Okay.
Kang buding dah.
Welcome, Balloon Show. Please take a seat. There's plenty of seats on the right side. Push. Yeah. Gorgeous.
Okay.
Releasing some balloons. Watch your step. All right. Let's have this one. Okay, over there. All right, finally we got 2 balloons left. Okay.
Whoa. All right, let me give out mine first, and then we'll have just one left.
Good job. coming out of the balloon? Air, right? And if we look at this scientifically, put our science hat on, we will see that the air is coming out in which direction? If I hold it like this, it's down or up. That air is coming out of the balloon downwards, and that makes the balloon travel upwards. Yeah, and believe it or not, it took a very famous scientist called Isaac Newton to figure out how balloons fly through the air.
So what did he say?
He said that every action has an equal and opposite reaction. So the force or the action of the air coming out downwards actually always creates a equal and opposite force pushing the balloon in the other direction. So enough of that. Who wants this balloon?
The final balloon.
Okay, well, one more countdown, okay? Starting from 5, 4, 3, 2,
and
1. Are you ready?
Everybody's ready. Whoa! Okay. Nice, Andrew, nice. Now, you have shown off your rocket balloons. I have a very special balloon to show off.
Yeah.
I have the very, very powerful balloon.
Powerful?
I'm not giving out my powerful balloon. It's powerful balloon.
This is powerful. How powerful? Does it fly through the air?
No, Andrew, no! You can use my powerful balloon to lift up your coffee mug without touching the mug.
Oh.
Yes, can you do it?
Lift up this mug.
Yeah, without touching the mug.
I know. What should I do? Tie it. Yes. Ta-da!
No! The balloon must be fitted in this mug.
What you do now? Blow it!
What?
No, it still doesn't lift up.
No! You're not doing it the right way. You need some lung power as well.
Huh?
Yeah, I'm going to inflate the balloon into the mug, if possible.
Oh.
And now I can lift up the mug at the count of 3, 2, and 1. See? You're popping up. It's very powerful.
It's not that powerful.
It is powerful.
Is this milk very big?
It is big. And
It's big. It's not that big. It's big, but it's not big compared to that balloon. What would make that balloon really powerful would be if you can lift up something really big. Like this giant bucket.
okay, there is nothing that my powerful balloon can't do.
Are you sure?
Let me measure this. Actually, you know, the thing about balloons is that you can stretch the balloon. So I'm going to stretch it. Stretch it.
Stretch it. I don't think you'll stretch that much.
Stretch it very. See? I stretched the balloon.
What happened to the Science Center logo?
I stretched it and then it came off.
Oh.
Yeah.
Okay. Alright,
Okay.
so
Now, I will lift up your mug. Okay. What is this?
good luck inflating that balloon. It's gonna take a lot.
Don't worry, my lungs are very powerful.
Oh.
I don't think I can do this.
Maybe I can help. Here, have my hair dryer.
You know what? I think I'll use my hair dryer. 1, 2, and 3. See? My hair dryer is really powerful.
It's like a giant eggplant.
Okay, so at the count of 3, okay? 3, 2, 1, and ta-da!
Very nice. It is, let's give it a pull out. Oh, yep, it's stuck in there. Put it
Exactly. Now, actually, yes, it's because of friction. There was friction between the surface of the balloon and the mug as well as the pill. And you know, friction is a really powerful force. That is what prevents you from slipping and falling when you're walking.
Yeah, and if you rub your hands together, you can feel another effect of friction, is that it also can generate heat as well. There you go. Ooh.
That's right. So there you go, my powerful balloon.
Okay, so we've seen balloons flying through the air, and we've seen that balloons can lift up things as well using forces, friction. But I've got a very powerful balloon too. And this balloon, which one is it?
Another powerful balloon?
This balloon cannot pop. And what's the best or worst thing about balloons is that they can pop and burst. Ooh, very loud. But don't worry, I have a balloon that will not pop. So those that are afraid of popping balloons, you don't have to worry. This balloon is so powerful, it will not pop. I think it's this one here.
Really? You say it cannot pop.
Yeah, maybe it was the wrong balloon.
Wrong color?
Okay. I think that balloon will not pop.
Something is wrong with your balloon.
I'm sure I have the right balloon here somewhere. That one, this one, I don't know. Aha! I think, now, this balloon, as I was saying, will not pop. As if you put a plate.
What?
See that, please?
I was trying the experiment for you to say it will not pop.
Now I know why my balloons are not popping.
Yeah.
But there is a way to make this balloon pop, to stop this balloon from popping. Where should we put the pointy stick? At the side? Yes?
Yes. That's
If you want it to burst again, it should go at the side. But I do not want it to burst, so I'm going to put the pointy stick at the bottom. Ooh.
Oh.
In fact, by poking the balloon here, it's the strongest part of the balloon. Because the balloon is stretched more on the sides and stretched the least at the end. So if you use the end, it's less likely to burst or tear. And it looks like this pointy stick is having a bit of trouble getting through the rubber. There's too much friction. So I'm going to use something like this.
Is that from the toilet?
No.
No?
Oh, hang on. Oh. Okay.
Ew.
This is oil.
Same.
Okay, and this obviously the oil is very slippery, and it will help the pointy stick to go in more easily with less friction, and so it also will reduce the chances of the rubber tearing. So here we go. Ooh, in one end, there we are. And now let's see if we can go all the way through to the top. So remember, the top and the bottom of the balloon are the strongest parts of the balloon because they are the parts that are least stretched. Ooh, oh dear. Now I have to be good at
Whoa, it's becoming strong.
air is coming out now. Don't scare me. This may take a while. Okay, there we go.
Yay.
Found it. Here we go.
It's coming. It's a bit stubborn. Yay! Ta-da! Amazing, Andrew. Okay, nice.
Okay. What's a barbecue? Satay.
Yes, especially with oil some more. Okay, now Andrew, talking about
high so everybody can see. Now hold it tightly a bit. There you go. Oh, is it gonna wobble? Okay.
Okay.
Alright. You ready?
Alright.
Let's go. I can help you hold it as well.
Okay, can I ask Andrew to help you hold, okay?
That's okay. Alright, are you ready?
Okay. Now, what I'm going to do is I'm going to slowly lower this balloon down into the fire. If you feel that we should bring it lower, you should shout, lower! But if you see her, oh man, so poor thing, you know, we should not bully her. So if you do not want me to bring it down, you should shout, lower! Yes, who was that? Awesome. You know me very well. Okay, okay. So you know what to shout. 1, 2, 3.
Oh, very brave! Oh, look, souvenir for you. There you go. Okay, so.
Okay, but you know, Andrew, that wasn't my main experiment. Sit down, sit down, sit down. I have one more question for you. Are you afraid of water? No. Oh, of course. You know how you bathe every day. So, we are going to bring out another special balloon.
This balloon has, can you see what is inside? Water.
Is your mommy here? Are you here with your family? Mommy, did you bring an extra set of clothes for her? No, it's okay. I like it. We'll give you some clothes. Okay, don't worry. Alright? So, be brave. Oh, but. Okay, you know, Andrew, we are very nice to our volunteers.
Oh.
Yeah, I actually have prepared an umbrella for her.
Oh, okay, very nice. Umbrella.
Yeah. In case something happens, this umbrella will save you.
Okay, no.
Why you laugh at my umbrella?
Baba, that's very mean. That's very mean.
Really?
Never mind, don't worry. I've got a proper umbrella for you. This umbrella is not broken, but it is very small.
You are worse than me, Andrew.
There we go.
Okay, you can protect your favorite part of your face, okay? Okay?
Okay, are you ready? Again. So, will the balloon burst? Who says yes? Anybody say no? Okay, wait. One more question. Who wants the balloon to burst?
You see, all these are the naughty ones.
Yes! Oh, okay.
She wants the balloon to burst. She wants a free shower.
Okay, are you ready? Let's give it a try. So,
Okay. Big fire.
umbrella, ready? Yep.
Okay, hold
Ready?
your umbrella. Alright, so what must you say?
Wait. Yeah, I think we need more fire.
Yeah, more fire.
Here we go.
Actually, it's pretty burnt, Andrew, see?
Wow. Hang on. So do you know why the balloon survived?
Why?
No, it's because of the umbrella. Is it right? Wait. Listen to my scientific logic. In the first experiment, was there any umbrella? No. Second experiment, was there an umbrella? Yes. Must be the umbrella.
No! Is it the umbrella? Of course not! Exactly, Andrew!
Then there's only one way to try it out.
Okay.
Put down the umbrella, please. Are you sure it's not the umbrella? Are you sure? Okay.
So you believe it will burst now? Oh, he will give you 5,000.
Are you sure? Okay, here we go.
Have faith. Here we go.
Oh, not the umbrella.
Not the umbrella.
Oh. So it must be the water.
Yes, that's right. Now let's
sure it is. And it will stop a lot of the heat energy from this fire will go into the water, not into the skin of the balloon.
Exactly.
Tear. Okay, so if you do it at the bottom, it should stay there for a good minute or two.
Quite some time.
Yeah. But if you would put the fire at the side where there is less water, then what will happen?
Challenge for you.
Really?
Yeah. I want you to keep this green balloon afloat for at least 30 seconds without touching the balloon. Afloat in the air.
Without touching?
Yes. Don't get anyone else to touch as well.
Oh, but what's that over there?
What? There's nothing there. No, 30 seconds, Andrew. Come on.
A what? I knew I brought this for something.
Oh, so you're going to use your hair dryer.
Okay.
Okay, let's see.
Keep it afloat in the air.
Yeah.
So think about hair dryers that the air is very... Yeah, it's not fast. It also can be hot as well. But it's the fast moving air that we're interested in here.
Okay.
So, turn it on. Speed number 1.
Nice. Andrew, how come it doesn't go right up?
Well, gravity is pulling everything down, right? So gravity is pulling the balloon down, but because of this fast-moving air, it creates upward force caused by something called difference in pressure. Low pressure caught in the fast-moving air, high pressure in the slow-moving air, causing the slow-moving air to go inwards and push the balloon upwards.
Very nice, very nice. Andrew?
Yes?
You gave me a bigger challenge just now. So I am going to give you a bigger challenge. I'm going to see how powerful your hair dryer is.
Is that big enough?
Is this big enough? Bigger,
Okay,
bigger,
bring it on.
just slightly bigger.
I'm sure my hair dryer.
Alright.
Alright, here we go.
This looks like a very big, fat orange. Orange!
Okay.
Okay.
Alright, so all we need is...
Come on, do it with your hair dryer. 1, 2, and...
fast-moving air. Here we go.
3.
Working. It's working. It's working.
It's not working, Andrew.
Oh.
You need my hair dryer.
Okay, so...
Okay, let's try with my hair dryer. Okay, let me get the balloon.
A heavier balloon obviously means, faster moving air.
That's right.
Alright, so faster moving air will create a bigger difference in pressure, basically giving us a bigger upward force.
Okay, here you
Okay.
go. 1, 2, and 3. Float. This is a really heavy balloon.
The dancing balloon.
Oh, okay.
Just about.
Yes. So
All
with
right.
that, we've come to the end of our balloon science show. Thank you very much.
Okay, thank you. Bye-bye.
Have a nice day. Here you go.
Are eh? Manda na to. Ibalik nga ni. Yes. Rock star. Pressure lang. Marto dito. Gawas ang utot ko. Ay? Sensor lang. Ay, taop. Where are we? Hit me? Hey, Coach Chuk.
That was hit.
Hey! Ngani wano, ngani. Okay.
Oh.
Eh, kan wajar. Ngawat. Lamikin din. Ayun. Hindi maklaro pa tungod sa ka. I don't understand. Put two eyes siguro. Reading! Na-end. Si Mama.
That reservoir is what we call the beacon. It has two endpoints or discharge points. Focus all your attention on these two endpoints because that's where all the action will be for our very first demonstration. But before we begin, as usual, some safety precautions. Is there anyone in the audience who's wearing an electrical pacemaker? I repeat, is there anyone in this audience who's wearing an electrical pacemaker as you're suffering from a heart condition? Please exit this atrium into any one of the exhibition halls, as the upcoming demonstrations may not be suitable for you. Secondly, parents with kids, please ensure that they do not climb on the metal barricades or touch these metal wires in front, because these structures are protecting us from the harmful effects of 3.5 million volts of electricity. And finally, the upcoming demonstrations are going to be very, very loud. So if you do not like loud noises, or if you're afraid of loud noises, remember to cover up your ears to protect your hearing every time I give you the signal. So now let me hear how enthusiastic everyone is for our first demonstration. Are you all ready for our first demonstration?
Yeah.
Very good. Eyes on the pinwheel, hands over your ears, and here we go. Wow, did you see the break of light? Go! Wow, beautiful! And here we go! An applause for it! I'm not convincing you to better than this. Are you all ready? That's more like it. Eyes on the balloons, hands in your ears, and here we go! Wow, that was a quick exploding noise!
Living with viruses. Dola.
Hand sanitizer.
SARS. Ano siya?
Magbanag ito dito. Si Puting ko mo ni Kamo. Ako nakag-ibong-ibong bracelet. Uy! That's Puting! Ah, Puting! Uy, may contamination na yan. Masunod mo guys. Wala nung decontamination.
Contaminate ako sama. Ora.
Sakti yan. May ma-post pa sa sakti yan.
Ay.
Don't be shy. I'm not. But I can't stand up. I can't do anything to you from here.
How about you? Are you afraid?
Didi. Grabe, badigan na lang.
Real life sa iyan. Real life, pero large lang.
Kita mo. Kid Jepper. My name's Kid Jepper now.
Kita pa ng tiyog naman, hindi ka lang magkali. Thank you.
Hello. Yes. Yeah. Call me later. Later, baby. Hey, I just met you. Hello? What's that? Oh yeah. Yeah. Datang. I see your ilok.
1, 2, 3.
Huwag ka na sabi ni ba?
Okay. 1, 2, 3. 1, 2, 3.
Kapal na siya si 1, 2, 3 ron.
1, 2, 3.
Oh, tarap pa siya.
1, 2, 3. Infected virus mouth.
Hi.
Oh, bus.
Let's go home now.
Sorry, cars, ano?
Oh, bus.
And that describes one of those. So there's nothing that really stood out to say this was just another case of pneumonia.